Hey guys, welcome back. I hope you're having a great day. Today I'm going to be making a video on lesson 5-5 in geometry, and I'm actually making this a separate video than 5-6, because if I were to make them both together it'd just be way too long, and I don't think I'd be able to keep your attention. So we're going to start with the theorems covered in this lesson, and it's basically the angle-side relationships in triangles. Now, this sounds complicated, but it's really not. We'll get into that. So we have this triangle here, and we know that AB, so this segment right here, is larger than this segment BC. So we'll go ahead and write that down. AB is larger than BC. All right, let's just say that. Now, what do we know about the angles when we know, based off of what we know about the lengths of these sides? Well, because of these relationships, we're given the information that the angle opposite the largest side of a triangle is going to be greater than the angle opposite the smaller side of the triangle. So because AB is larger than BC, we know that the opposite angle of AB, which is C, is going to be greater than the opposite angle of the smaller side, BC, which would be A. So we know that the measurement of angle C is going to be greater than the measurement of angle A. We can also use this in reverse. We can know that angle C is larger than angle A, which means that the side opposite to this angle is going to be larger than the side opposite to the smaller angle. So that would mean that if C is larger than A, that AB is larger than BC. So let's go ahead and look at a problem that applies this newfound information. We're given these three side lengths. We're given 30, 40, and 70. Okay, so what do we know? Well, we know that 30 is the smallest side, 40 is kind of in the middle, and 70 is the largest side. So based upon this theorem that we learned up here, we know that the angle opposite of the smallest side is going to be the smallest angle. We know that the angle opposite kind of the middle lengthed side is going to be the middle of the large and the smallest angles. And we know that the angle opposite the largest side is going to be the largest angle. So right now, we're being asked to give the measures of the angles in terms of the smallest angle to the largest angle. So because AC is 30 and it's the smallest of the sides, we know that its opposite angle, B, is going to be the smallest angle. So we know that angle B is going to be smaller than everything else over here. We know that 40 is in the middle of 30 and 70, so that its opposite angle is going to be the middle in terms of the measure. So we know that C is opposite 40, so we know that C is kind of going to be in the middle. We know that 70 is the largest side. A is opposite to 70, this side, BC, so we know that angle A is going to be the largest of the angles of this triangle. Okay, let's take a look at another example. Now, instead of involving ourselves with the side measures, we're going to involve ourselves with these angle measures. So we know that this angle measures 30 degrees, and this measure angle is 45 degrees. And you say, oh, well, 30 is less than 45, so this is going to be the smallest side, and then this is going to be the larger side. But you go over here to look at what this angle is, and, well, it's not there. But we know from the triangle addition, or the triangle sum theory, that all of the angles of a triangle add up to be 180 degrees. So that means we can simply add these two angles together, subtract it from 180, and know this third angle. So let's go ahead and do that. 30 plus 45 is 75. And if you subtract 180 by 75, you're going to come out with 105. Now I know this angle doesn't look at all like 105 degrees, but we're just going to say that's what it is. So, based upon this information, we can call these vertices whatever we want. So let's go ahead and make it x, y, and z. Alright, so we're being asked to give the side lengths in terms of the smallest to the largest. So we know that 30 is the smallest of these angles, which means that its opposite side, xz, is going to be the smallest of the sides. So xz is smaller than everything else to the right of it. We know that 45 is the next smallest, which means its opposite side, yz, is going to be the second smallest side. We also know that 105 is the largest angle measure. We know that xy is opposite this angle measure, so we know that xy is going to be the largest of the sides. Alright. Now, later on in the chapter, we're given another theorem. It's called the triangle inequality theorem. And basically what it states is that out of the 3 side measures of a triangle that you have, you know that no matter which 2 you choose, when you add them together, the product is going to be greater than the third measure. So let's go ahead and use the same figure. Let's call this side 5. Let's go ahead and call this side 4. And let's go ahead and call this side 7. Okay. So, we know that 5 plus 4 is 9. That is greater than the remaining 7. We know that 7 plus 4 is 11, which is greater than the remaining 5. And we know that 7 plus 5 is 12, which is greater than the remaining 4. So let's go ahead and apply this information to some problems we have here. We want to know if a triangle, quote unquote, that has the side lengths of 7, 9, and 30 is actually a true triangle. So as a little trick, you can actually use the 2 smallest measures you're given and add them together. Now, if they come out to be greater than the third, you know you're set. You know that's a triangle. But if they don't, you automatically know that's not going to work out. So let's take 7, add it to 9. That's going to come out to be 16, which is unfortunately smaller than 30. So no, this is not a triangle. Let's take a look at this one. Well, 5 and 5 are smaller than 10, so we know that 5 plus 5 has to be smaller than 10. So let's check that. Is 10 smaller than 10? No, 10 is equal to 10. And even that won't make a triangle. So no, that is not going to work. Let's go over here to this third examples. I included some fractions here just because I know we all don't like them, but they're not as scary as you think. So let's go ahead and take 4.5 and 7.5 and add them together. Well, 4 plus 7 is 11, and half plus half is 1. So 11 plus 1 is going to be 12. Now, is 12 greater than 20 and 3/4? No. So it is not a triangle either. You will have problems in the homework where it does come out to be a triangle, but we don't have any in these examples. Alright, we're getting near the end here, and this is the last thing we're being asked to do. Now, these are actually going to have to involve some algebraic inequalities, and all that means is that instead of having an equation with an equal sign, we're going to have kind of like an equation, but with a greater, less than, or greater and equal than, and all that sort of stuff, instead of an equal sign. So we're asked, what are the ranges of the length of the third side when we're giving these 2 sides? And we can actually do that algebraically. So if you take a look, we know that the sum of 2 sides have to be greater than the amount of the length of the remaining side. So let's say x is the third side length. We know that 4 plus 20 must be greater than x. When you do the math, that comes out to be 24 must be greater than x. Alright, now that's good. Now let's take a look here at 4 plus x has to be greater than 20. Alright, now we can subtract 4, we can subtract 4 on this side, and we get x is greater than 16. So when you put these 2 together, you know that x has to be greater than 16 but less than 24. So this can be written 16 is less than x, which is less than 24. And here you have the range of this third side. So this third side could be 17, 18, 19, 20, 21, 22, or 23, but it cannot be 16 or lower, and it cannot be 24 or lower. So let's go ahead and take a look at these two sides. We're going to do the same thing that we did in this problem. And we'll go ahead and take a look. So we know that 9 plus 7 must be greater than x. So that's going to come out to be 16 is greater than x. Connect the dots up there. All right. Now let's take a look at something a bit different. You might kind of run into this problem when you're doing the homework and you won't really get why it won't quite work out. So let's take x plus 9 must be greater than 7. And you subtract the 9s and you realize that x has to be greater than -2. Okay, here's the deal. Because it's a length, it has to be greater than -2. You can't have a negative length. So that's a kind of a given. So if you run into one of these problems, you can normally just avoid setting up this problem where you get a negative answer. But if you do, you know that you kind of have to do it for the remaining combination. So you know that you're going to have x plus 7 is greater than 9. Okay? So we're going to subtract 7 from each side, and we're going to get x must be greater than 2. And obviously, this will yield that x must be less than 16, but more than 2. And that looks like, I'm running out of room here. This looks like 2 is less than x, which is less than 16. So I hope this helped. If it did, leave a comment and let me know how I can improve what I did wrong. And if you just have any questions about the math or the suggestion for another video for me to do, go ahead and let me know. So I hope this helped, and I hope you have a great day.